Yeah, so I got called up 3 days ago to give this talk, and then I decided to completely pivot. So um, I've changed the talk a lot. So if you guys thought you've seen it, you haven't. It's not all new, but there's a lot of new content in it. Um, but anyway, like he was saying, I am Chris Bailey. I do organize the Triangle DevOps meetup group here locally in the Triangle, 3,200 members. It's a phenomenal meetup group. A lot of the speakers that are actually speaking here have given those talks at the meetup. We have a great relationship with DevOpsDays Raleigh. And then also I am the managed services lead at a company called Terrazzo, and they build API platforms. So if you're interested in anything about that, you can talk to me after this. I'm also a huge racing fan, so this is me in the rain at Charlotte at 140 miles an hour in a Corvette. And this is also me in a much smaller car being chased by a much larger Camaro. So Hemingway put it best when he said there are only three sports: bullfighting, motor racing, and mountaineering. All the rest are merely games. And as you guys know, televised numbers for mountaineering and bullfighting are through the roof. So, but motor racing actually is the most televised sport in the entire world. Last year for Formula One, halfway through the season, they had 3.6 billion viewers. So it's way on up there. But this is auto racing. So auto racing is this phenomenal thing. You watch your favorite driver. They go around a couple different ways. They either go around, make left and right turns, or just left turns, or they don't turn at all. But either way, these cars, these vehicles are pinnacles of engineering. The amount of engineering that goes into these at all levels, including NASCAR, is astounding, right? There's teams of engineers that work on them day and night. And just absolutely fantastic from an engineering perspective. But with that, so when you have the best drivers in the world, for instance, Formula One, these guys have moved up. They're considered the best in the world. Every advantage counts. So there's this amazing quote by Cyril Abiteboul. He's the managing director of the Renault team. Take the best driver in the world, you give him a crappy car, guess what? He's not going to do too hot. So I should have just read the quote. That's my version of it. But yeah, so the engineering aspect of this is huge. And I've run DevOps teams now for about 3 or 4 years. And one of my favorite quotes to just impart on every person I've ever managed is this quote by Colin Chapman. Colin Chapman founded the Lotus Racing team way back in the day. And that is simplify and then add lightness. So make the cars as simple as humanly possible, and then start pulling things out until it's as light as possible. I didn't actually know this existed, but then looking at the Manifesto for Agile Software Development, sounds really similar. Simplicity, the art of maximizing the work not done, is essential. So this idea of simplicity transcends beyond just racing. It applies in engineering. This guy, Albert Einstein, can't explain it simply. You don't understand it well enough. So you're going to hear a lot of me referring back to this simplify and then add lightness throughout the talk. But it's an absolute phenomenal sentiment to live by. So starting out with how auto racing can or is related to DevOps, we go into culture. And so when you think of racing, if you're not a huge racing fan, which by the way, how many people here watched auto racing, race your own car? Okay, yeah, like 2 or 3 of you. So at the end of the day, when we are spectators, we're watching our favorite driver usually, and we're cheering for them, and they cross the finish line, and they get up on the podium, and they spray champagne on each other, and that is, what we consider watching racing, right? It's that driver, he's driving at the limit, he's bested everyone else. But at the end of the day, the amount of work that went into building that car is astounding. So this is the Williams F1 car. That on the wing plate there is every engineer that worked on the car. So over 200 engineers had something to do with the car. And this goes from the people on the pit wall who are doing logistics, reporting back to the driver, reporting back to the engineers, the single guy who built that engine apparently. So it's an absolute group effort. But one of the big things about auto racing that I think can teach us something in DevOps is we all work for companies where it's hard to get behind the message. A lot of CEOs, VPs of engineering don't really know how to communicate business value. But if we can align like racing does, right? No matter what part of the team you are all fighting for the exact same thing. It's incredibly easy to celebrate wins, and it's also incredibly easy to be enthusiastic about what you do. The way that you celebrate is when that happens, right? And so everyone within the organization is pushing for that win. Even the IT guy that fixes the laptop of the guy that tunes the car, when his driver comes across the finish line, he feels like he's celebrating that success. I don't have a solution for that, by the way, but it is something that's like, when you're that driven by one goal, it's so easy to align behind it. So also within culture, and we'll see if this plays, so there's the idea, I'm going to pause it. I'm going to pause this for a second. But there's the idea of safety culture within the DevOps community. And safety culture is where you're okay to fail, you're okay to push the limits, you're okay to try new things, experiment, right? And the idea that when you do those things, you're not going to be hung out to dry for that. That's where the concept of blameless postmortems come from. So I was like, how is there safety culture in racing? Well, I'll show you a little video. So that's a wreck from Le Mans. That's Alan McNish in the Audi. How safety culture applies within auto racing is that the engineers have built a car that is so safe that allows that driver to push the limit beyond, again, went over the limit there, actually ran into someone, but point being is that in the same way, not in the whole like you can fail and everything, but they've given him a car where he can drive over the limit, where he can make mistakes, and that's okay. He's not worried about the fact that, he's going to die. It's a terrible, terrible accident. You can see the car is absolutely ripped apart. But yeah, he got out of the car, climbed out of the car, and walked away from it. So, additionally, there's also the concept in DevOps of a learning and generative culture. And a learning culture means that you're constantly learning, you're taking what you've learned before, and you are iterating upon it. You're never happy with the status quo. You always are wanting to improve. And so here's a really good example. This is from Formula One. These are all the individual wings designs from different Formula One cars. And what's crazy about this is these guys, in order to find performance and speed, will make tiny little changes to these wings, iterate over them over the course of a season, and that might be the difference between coming in second place or first place or third place. This recently occurred with Ferrari. They're the red one. They added those two tiny little wing plates, the two red ones, allowed them to win a race. Like, that's all it took. So, and again here with NASCAR, NASCAR rules, racing rules in general, they're not solid either. They're constantly iterating on that as well to allow the engineers to explore space, find all the loopholes that they can get through. And so it's just this constant iteration. But when it goes wrong, and so not only is there this huge engineering team, they're building a car and everything, that in Formula One, they have to ship that car to over 30 countries. They have to import all the parts from all over the place. They from different manufacturers. They're all over the, it's a logistical nightmare. And this is what happens when that goes wrong. So Fernando Alonso was attempting to participate in the Indy 500. He's going for what's called the Triple Crown of Motorsport. And they forgot his steering wheel. Like, this is real life, right? They didn't have his steering wheel in time. And so logistically, everything fell apart. He wasn't allowed to participate. They attempted to buy one off the shelf, which is a thing apparently you can do. Yeah, this is what Best Buy sells now, I guess. But couldn't find him a steering wheel, and he failed. So within the culture, thinking about logistical problems is actually a really good thing from a DevOps perspective as well. There's a game, it's called the MIT Beer Game, and it's about supply and demand and the flow of product. I actually have played it. It's recommended by Gene Kim. I actually have played it with a couple of my teams. It's a really fantastic way to see how communication breaks down, how to identify bottlenecks, how to optimize processes, and especially, more than anything, how to communicate with each other, right? I have too much, please don't make any more. Oh, you're still making more, please stop. So, fantastic game, would totally recommend it. So moving into observability. Observability is my favorite DevOps thing, just because every time you type it, no matter what you're using, it has like a little squiggly under it, and everything wants to fix it. But and for those of you who have seen it, this is the same. So the modern Formula One car has over 200 sensors on it, detecting things like wheel speed, temperature, the amount of air that is flowing over certain parts, the driver's heart rate, all the biometrics from the driver. Within one lap of a Formula One race, they collect 2 gigabytes of data. And it's incredible because they've actually had to design this fiber optic mesh network that gets the data back to the pit lane as fast as humanly possible, because you need this kind of data within millisecond response time. But yeah, so they collect everything that they possibly can about the car. In the 2014 US Grand Prix, over one single race weekend, you had 243 terabytes of data collected. I've given this statistic before, but all of the weather data for the last 150 years fits in less than 150 terabytes of data. That's like wind, air pressure, all of that. Yeah. So if weather had sponsorship, we'd collect more data. Oh, that's a terrible thought. Advertising on a hurricane. Okay, so McLaren built this tool called the Atlas tool, and that's what this is. This is a lap around Monaco, specifically looking at the data. And you can see the speed of the driver. I'm not going to go over too much of it, but you can see the speed of the driver, how far they're turning the steering wheel, how they're manipulating the brake and gas, how much slip angle they have, all sorts of data from just this. And it's all in real time. So they're collecting all of this. They're able to plot it. They're also able to compare it against the teammates. So you might come in and they're like, you're slower compared to whomever here and here. But this transcends, I mean, we've all looked at graphs plenty of times, but this transcends even outside of this. So this data collection system that they run is so fast, so advanced to collect this kind of data that they piloted it at a pediatric hospital. And if you don't know this, they don't collect historical data on your, like, if you have a heart attack, it happens, like they don't collect it. But they did with this. And so this is using the McLaren Atlas system. That is a child having a heart attack there, so you can see the spike. So has application across the board. And this, so this is actually my data compared to my driving coach's data. From a learning perspective, being able to compare this data being able to look at it, and again with systems, being able to look at disparate systems, compare them, how are they different, how are they the same? How are they not performant? How can I fix that? This honestly has been an incredibly valuable tool for me. You can see like where I'm slow, where I'm fast, where he's slow, where he's fast. I'm not slow anywhere on this, by the way. So moving on from there into performance in DevOps. It's something that we don't talk about a lot. A lot of times with performance, especially with application performance, it's something that's thrown over the wall, right? So if you have a slow web app, typically that's, well, the developers need to write better code, right? Or they need to optimize PHP or whatever Node or whatever it is, right? But we as DevOps engineers, SREs, whatever, have just as much responsibility for the performance of an application as the developers. So this is the pit crew for Williams yet again. This is pretty crazy. So within a pit stop, I will only reference Formula 1 for pit stops because this is absolutely amazing. But a pit stop cycle that is slow, for instance, someone like bobbling a tire or not getting the nut that holds the tire on off correctly, is enough to lose a race. So this is the world record. Yeah. So just as a curiosity, and I'm going to be interactive with everyone, how fast do you think that was? No, that is a different slide. Anyone? 3 seconds. This is Price is Right rules. Bust. Yes, you. Do you want a toaster? 2 seconds? 1.91 seconds for four tires to be changed on the car. Take them off, put new ones on, drive away. So the way that they did this is when you're looking for any kind of edge, for instance, Formula 1, they installed biometric sensors on every single one of that pit crew that's standing around there, and they collected data on like how they were moving, like how they, where they were slow, where they were fast, and then in order to improve that, not only did they collect the data, they adapted their workouts based on what they did. So there is a guy that lifts the tire on, and then there is a guy that like takes the nut off and puts the new nut on. Well, they're different guns, but so they adapted based on this data that the guy that lifts the tire is going to do different exercises in the gym than the guy that does the gun, which allowed them to find this kind of pace and set a world record. But that's the kind of like performance that you're looking for there. So 1 extra second can also lose the internet race. Is there an internet? I don't know. So Marissa Mayer, she used to be CEO of Yahoo, said they did a study, and she said users really respond to speed. The average web page load time, and this is a little bit skewed, mainly because this covers multiple industries. Your like big industrial companies don't care how long your page loads, but average page load time is 8.66 seconds. That doesn't seem like an eternity. If anyone here drives a Mazda Miata, that's how fast you get to 60 miles an hour. But a Formula 1 car hits almost 190 miles an hour in less time than most websites take to load. So it's really slow, like slow internet. Everyone hates it. And sometimes when I show this slide, I get people that are like, 8 seconds is not a lot. But I can tell you, as a DevOps person, anytime my internet feels slow, I just want to throw things and scream and rage around. And then you hit the refresh button a million times. So again, putting this acceleration into perspective, of course not. So to the average human being, 100 milliseconds or less is instantaneous. If any of you are pro gamers, then you're probably going to throw something at me. But for the average person, 100 milliseconds or less is instantaneous, right? So that's 1/10 of a second. In this picture, we have a Formula One driver who is looking into his rearview mirror. The Formula One driver can actually identify the car that is behind him, glancing in the mirror for 100 milliseconds. So absolutely astounding. But in the world of the internet, 100 milliseconds of latency is really bad, right? So again, at Yahoo, they did a study. 100 milliseconds of latency cost them 1% of sales. Moving on from that, 500 milliseconds of page generation latency dropped traffic by 20%. And we're going to get back to why that occurred in just a second on this slide. So this is a company that improved their page load time by 5 seconds. They saw, again, a 10% increase in revenue, 25% increase in page views, a 50% reduction in hardware, and a 120% increase in traffic from Google. So if you guys don't know this about Google, with PageRank, if your site is slow, your results show up below everyone else's. So if you are a company with competitors and their page loads faster, they appear higher on the results. And then if they also pay for ads, then they're higher too. But all things being equal, the faster page load times, the higher up on Google PageRank you're going to be. So moving into chaos engineering. Chaos engineering is a pretty new thing in DevOps. Well, not that new. But this all started gaining massive adoption when Netflix was like, we take down one of our regions of AWS and we see how it reacts. And they have their whole simian army that takes different scales of their product down, and then they react to it. So with chaos engineering, the big thing about that is practicing what's going to happen and planning for contingencies for when it does. And so within racing, Formula One, this is a professional Formula One driver, Max Verstappen, and he has his Beats headphones on, and he is practicing in their simulator. It's not the real thing, but it allows him to see what the track looks like, how the surface works, all that kind of stuff. Actually, a lot of times these guys, so there's a new driver in Formula One, Alex Albon. He had never raced a track before in Singapore, so he raced on a simulator, and he was able to pick it up very quickly in a real car doing real 200 miles an hour. So same thing here. You can have this at home. You can practice. That's going to run you like $40,000, but it looked good. But point being is that even though this is a professional $200,000 plus simulator for their driver, collecting massive amounts of data, even if you're a small, tiny company, you can also do the same thing, right? You can test your infrastructure. You can simulate outages. You can do game days, which are worth their weight in gold. What happens when we have a DR issue, right? We actually we built our DR stuff. And just for, how many of you guys have set up disaster recovery? Right? How many of you guys have tested it? Okay. How many of you did it work the first time? And then finally, if I was to shut down USD Swan right now, how empty would this room be? Okay, exactly. So being able to test those scenarios, test those situations, exactly that, right? Like the company I was previously working for, we have our DR in Oregon. If you were to shut down USD Swan right now, then we're not making any money. No one's probably making any money, but planning for those contingencies, simulating, which I think is really important, being able to build up infrastructure that's not real, and experiment against it, right? So one of the things with this is, going back to this, is that in this safe space for him, he can push the limit as much as he wants to. In a car where he's doing this for real, and he wants to see what taking a different line or hitting the accelerator early, that's dangerous. But here he can really test and push limits. A lot of people don't know this, but they do crash simulations in the exact same way that they do for like the Transportation Institute. So they put a dummy in a car and then they just slam it against the wall. But same thing, right, is they're looking to see how that carbon monocoque is going to fail so that they know, right? So when a real incident happens, we know exactly how it's going to compress. We know exactly how it's going to fall apart. We can institute the things to protect the driver. If you've watched any modern Formula One, they have the halos now. Everyone had a huge backlash about this, but the halo protects the driver from pieces of the car coming back and hitting them in the head and killing them. And they've done this forever. So auto racing has done this for a really long time. The one thing I will say is I love the fact that they dressed up that test dummy, and he also looks like he's listening to like some sort of metal music. But yeah, so I think that picture is something like 50 years old. And then even with their pit stops, right? So most people in this room have run books that you have an incident happen, you go and you write your run book, right? And then you don't worry about it, or you hand it off to a junior engineer. How often do you ever go back to those run books and test against them, try them out again, update the documentation? No one ever does that. And then you get to a run book, and then you take someone's name in vain who probably isn't at the company anymore, and it's like, this isn't how this works, right? So here, this is at Le Mans. This is Ford practicing pit stops. So again, coming to the pits, literally just scrambling. They fake things failing. So something on the car is wrong. What do we do in that situation? And they time it, and they test against it. With all of that, putting all of that together, this Lexus has had a bad day and a pretty massive accident. Completely torn off the front end of the car, right? This happened in practice. If you know anything about racing, though, unlike most sports, if you tear your ACL, you're out for a little while. But that's a torn ACL to a race car driver, right? They rebuilt that entire car in 9 hours. And the way that and completely ready to go, participated, I don't know how well they did, but were able to get back on the road from something that, honestly, like the adjuster would be like, your car's totaled. Why am I wasting my time? But the way that they were able to build that up so quickly, 9 hours, is they tested. They tried. How quickly can I do this? How fast can I, or how quickly can we change? They drilled on it. Also, this car is driven by this guy. Don't know if you guys know this, but this is some of the crossover. But that's David Hennemeyer Hansen at Ruby on Rails. And then here at the end, just because we were talking about the Simian Army and the chaos engineer, I just wanted to put a gorilla in a car. So innovation. One of the things that we see a lot in DevOps is that people can get really tool heavy, right? For my monitoring solution, I use Prometheus. Oh, I love Ansible, right? I write this DSL. Oh, Chef or Puppet, right? And then you interview them, and then that's it, right? The tools. But one of the major things with innovation is, it's the first time I've looked at that 1 minute. One of the things with innovation is we need to be looking beyond the tools. If something doesn't exist that you need, right? So maybe you have to write it. Maybe it's something that you build and invent and do that. I think we're a little bit afraid of that in DevOps, right? Ansible won't do it, then I'm just not going to do it. I'm going to write a bash script or whatever it is. But some innovations from racing, and in the same way that you might write a tool that becomes Ansible, the rearview mirror was invented for race car drivers so that they could see the competition coming up behind them. And that was the last time that a rearview mirror has ever been used since then, right? So here in North Carolina especially. These are disc brakes. These were invented as well, race car drivers. So every time you slow down, look in your rearview mirror and use your steel disc brakes, and then thank a race car driver. But even then, And this is the inflammatory picture. I was a little nervous to put it up here. But the world is changing, right? And we all pine for the days where cars are incredibly loud and screaming V12s and whatnot. This is Formula E. This is the electric cars. And this is the future. Manufacturers are all getting behind it. And you have to be able to be ready to move with that sea change, right? So, sure. And Chris Short's over there, one of the marketing people or for Ansible. I don't know what your title is. But Ansible is the solution for right now. Ansible might not be the solution for five years from now, right? Being able to identify this thing, there's a change coming, and maybe we want to move with it, maybe we don't. And then finally, I'm going to go super fast through this. 2 minutes. I'm over my time. Can I? Yeah, cool. So infrastructure as code. Infrastructure as code is capturing everything about your infrastructure in code. Man, I'm really good at this. But with the idea that you make everything repeatable, right? And you leverage everything that you can in programming, conditionals, why I want to do things, right? It's all Git managed, everything like that. So within racing, they do the exact same thing. This is the Toyota team at Le Mans. They're working on the car. Every part of the car that they can is compartmentalized. So if they need to replace something, for instance, those brake boosters on the front, it's very easy for them to switch that out. They have another one ready to go. In the same way that, so this race car to them, and it's an amazing parity between us, is that something we all push for in DevOps. That is cattle to them, right? Not kittens. So you guys probably heard this before. Treat your infrastructure like cattle, not kittens, right? You love to pet a kitten. You might love to pet cows too. But bad things happen to cows, just in case you guys didn't know that. But point being is that the car can completely be torn apart in an accident, right? And they don't care. Like, there's not a bunch of special snowflake stuff that has been done to the car. They just replace it wholesale. So if body parts are ruined, they replace it with a new one. In the same way that, your instance goes down, you just spin up another one. And who cares about that old one? Or, hey, we need to apply Linux patches. Let's just spin up a new instance. Some of the same thing. Same ideas. There's just all compartmentalized. So we started in the very beginning with how complex the Formula One wing is. You can see it there in the front. And with all the barge boards and all this crazy stuff, right? It's an aerodynamic wonder. So to replace that, or if you had an accident with that, probably going to be having a really bad day, right? I'm sure that wing probably costs over $100,000. They just throw in another one. Who cares, right? So the driver might have knocked part of it sideways, and yep, they just come in and they replace that. If you ever, I couldn't find a video of it, but if you ever watch them replace that, that takes them about 3 seconds. They turn a screw, they pop the old one off, they put the new one on. It's incredible stuff. But again, they're not worried, right? And then they throw the old one out. So to wrap this up, auto racing is incredibly old, right? This is 2001, I think. And then this is 2017. But we're still doing the same thing. But they're constantly iterating. I love that I just referred to myself as a researcher. Anyway, yeah, I'm right there in the front. They're constantly iterating, right? So while the goal is the same, right? You want to cross the finish line in first place. The technology, the way that things happen, the amount of advancement has just gone through the roof. And my final touchy-feely part of this is that enjoy what you're doing. It's really tough, right? We're all DevOps engineers. It can be stressful. That's Juan Manuel Fangio, and you can see he's covered in dirt because they didn't have windshields back then or seatbelts, but he's happy. He's smiling. Even if you come in third place, though, still smile. Same thing here. Just incredibly happy, right? So enjoy it. It's fun. And then this slide, which is just added here, is to go back to that whole just enjoy it. This is the Haas team. They're the only American Formula One team. And during this race weekend, they had an absolutely terrible weekend. Both cars retired. The drivers hit each other, like teammates hit each other. But even through all of that, Gunther Steiner, their team principal, still appreciated the schnitzels, which I think is really important, right? That's all he said in the interview. He's like, what did you take away from this race? The schnitzels. And then someone beat me to it, but Star Wars references. I mean, I'm at a DevOps conference, so I did put one here at the end just in case. So that takes care of that. Cool. Anyway, thank you guys.